Welcome to my talk on scripting today. Let there be scripts. Glad to see some interested parties in here. My name is Pontesegger. I'm the project lead of the Eclipse East project, which is what it's all about, this talk today. And I'd like to show you around in this project, what you can do with it. The first thing you need to know, eclipse.org/ease is a landing page where you can go to when you need more information on the project. You here can get download locations, documentation, channels for support if you have questions, or you can get in touch with the script repositories and see what we are doing in code. I'm showing this to you because we do have a repository to host scripts. Whatever I will show you today will be online on the scripts repository later on, so you don't have to take screenshots or write anything down or things like that. So all the examples will be here in the scripts repository. I'm not a fan of a lot of slides, but there is one thing I have to show you first. The big picture of ease. So we do have Eclipse as our development environment, or we do have an RCP based on Eclipse running on Java. And Eclipse comes with support for a lot of scripting languages already. So there's JSDT for JavaScript support. There's PyDev if you want to write Python code. There's Dynamic Language Toolkit available for diverse other languages. What they all have in common is they bring editor support, code highlighting, syntax highlighting, sometimes error checking and things like that. But when it comes to execute that code, they typically all use an external interpreter for your code, run the code there, and the best you can get is that the output is displayed in a console view in Eclipse. On the other hand, there are script engines and interpreters that run natively on Java. There is Rhino and Nashorn to interpret JavaScript code. Python, which is a genuine implementation of the Python language on Java. There are also similar things like Py4j, which is actually a kind of bridge between the Java world and the Python world so that they can interchange data with each other. And the idea of Easy is to combine these things, to combine the left-hand side with the right-hand side and to push everything into Eclipse. Run our scripts right in our IDE so that they also have access to Java directly. So this is the main concept and the main idea behind Ease. And now I want to immediately switch to demos and show you around. The first thing when you install Ease is you do get a new perspective called scripting. When you open that perspective, the most prominent thing you will see is the script shell in here. So it's a REPL kind shell where you can enter one-liners of commands and you immediately get the result as a feedback. So if you just enter a command, you can see the result right away in the script shell history. So JavaScript, as we have Rhino here, so we have a JavaScript interpreter running, but JavaScript itself is not a very powerful language regarding library support and things like that. The interesting thing is Rhino runs on a Java runtime, so it has access to Java classes. What you can do is, for example, you can create a new Java IO file object, put some path in there. I bind it to a variable. This is a JavaScript variable right now, f. And you can use the Java methods on this. So you can directly call in the Java stack using your script engine. Now, if you're running in the JRE and if you're running on the same Java that Eclipse runs on, the next native thing we actually wanted to do is to communicate with Eclipse itself. So all these folders come with some short HTML descriptions, what we are doing here. And if I copy over that line, please do something. Oh, I have to type it, okay. I can access the Eclipse workspace right away. So what I got here is an instance of the workspace you see on the left-hand side in the Project Explorer. And the idea is if I can access the workspace, I can also manipulate the workspace. So I could create a new project, for example, create new files, operate on those files in there. As you can see, when you look at that very long string I entered here, this is really cumbersome to do. So you do not want anybody to write these kind of lines to access the workspace, right? So it's quite complicated. When we invented Ease and that mechanism, one of the biggest topics was how can we make scripting simple to users? Our main users that we have in our company are people that are not well aware of coding at all. They have no clue of object orientation, try-catch statements and things like that. So it had to be really, really simple. What we came up with is a method called loadable modules. So think of modules as libraries that provide some functionality which you can push into your script interpreter. There were interpreters for Eclipse before. There was Eclipse Monkey, if somebody knows that project. A lot of this project came with a fixed stack of functionality that shoved everything into the editor or into the interpreter, and it wasn't extensible. So we try to do it in an extensible way. If we look at these modules here, the Modules Explorer gives you an overview of which kind of modules do we deliver with Eclipse. If you hover over a module, you will get help. If you hover over the methods of a module, you will get the dedicated help for that method, right? So it looks quite the same as the Java pop-ups you do get for Java methods. And if I want to load a module, I can either use drag and drop here in the shell, or I use the command load module to make the functionality of the module available in my script engine. What it actually does, it pushes all these methods to the global stack of my script engine, and now I can call get workspace, right? And I do get the same instance that I would have got with the very big line I entered at the very beginning of this talk. So modules are here to help you to simplify your tasks, to let your users write scripts in a very efficient and nitty way. The idea is that Ease doesn't ship modules for each and every plugin that's out there in the Eclipse universe. Instead, we do want other projects to adapt and to write their own modules for Ease and to contribute. So we had to find a simple way to write modules. And what a module looks alike, it's like this. This would be a very simple module. So you see, no dependencies to anything from Ease. This is just a classic Pojo, plain old Java object with no special augmentations to scripting. What we can do with this is we can parse that class, look for any kind of public methods you have in there, and make them available as module methods. The only thing we ask you is to implement an extension point, or to define data for an extension point, to let us know that the module is there and that we are able to show it to you in the Modules Explorer, that we know of that class, right? It takes ages to open up, sorry for that. In the end, what you have to provide for that extension point is just the class you're actually referring to and the name of the class you want to have it appear in the Modules Explorer. So finally, see, it looks like that. The interesting thing is, as you do not have to put any kind of augmentations in your class, you can use any kind of class and make a module out of it. So the Java AO file class we had would be a candidate for module, not a very good one, because you normally need to provide the name for the file. But you can push any class you have, any utility or helper class in there and have a module right away. So,
excuse me, Christian.
Yeah.
So sure. that method there is returning a string.
Yes.
Which I know Rhino would understand. If that returned a Java object in my application,
yes.
Would the scanner still spot it?
Yes. So as you've seen before, we created a Java IO file object here in the script engine. We did it by calling the constructor directly, but if your class, your greet, would return a file object or any kind of data object you have, this would still work here.
So it would be returned into the record.
Yes.
View.
Yeah.
But the user can't manipulate it then.
Oh, he can manipulate it. You get an instance and you can operate on that instance. You can do what any kind of functions you have. Any getter, any setter, anything that your class provides is accessible to you. Like it were Java code, there's no difference. Right? The only difference is that this is dynamic. For Java code, you have to write it, you have to compile it, even if Eclipse does it automatically, you have to deploy it and so on. You don't have to do that here. And let me show you a live example for that simple module here. We also, of course, if we can write script code in the shell, we can also push it to a file, right? And execute it from a file. So I have a file here that loads a module called JVM, which we also deliver with our default ease setup. JVM provides a method which is called createInstance. So it creates an instance of a class. And we do use those workspace URI scheme that we introduced for ease, which actually accesses our workspace. So the thing we have here on the left-hand side goes to the project EclipseCon 2017 source, blah, 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 until we find that Java file here. And we do create an instance of the file, which we store in a variable called module, and then we can access it right away without restarting anything. The wrap method here is what we do in the background to make all the functions of an instance available as your script function. So when I do the load module, I create an instance and internally do the wrap. So now I'm manually loading our class and call the greet method of the class. So, and if we try that out, you do see the return value, welcome script developers, which is the return value we got here. Right? So this is also a nice thing what you can use ease for, it's rapid prototyping. When you have a class, a utility class you want to play around with, you might not have unit tests yet and you just want to see how it performs, just push it in there without starting anything, you can run it, test it and try it out. We do have other modules, like we do have charting modules. Just we'll run the demo here that you can see what it's doing. What the charting module does, basically it calls the ping command in the background, the script for us, and creates that ping chart for us, just to showing ping statistics of different servers. In the company I'm working for, we use this to display measurement results live while we acquire data. So these diagrams can grow. You don't have to provide the data ready-made before you push it to the diagram. You can put point by point into the diagram and plot it step by step. Also a very nice thing. So we started to have those scripting engine, right? Then we started to have modules and now we provide our first scripts. When you do that and come up maybe with some utility scripts to clean up your workspace, to create a new project or things like that, you might want to store them somewhere where you can easily retrieve them. You do not want to have them cluttered all over your workspace in different folders, in different projects and so on. So that's what we came up with scripts for. So scripts are just JavaScript file, Python files, or any kind of other script that we do want to have more prominent in our IDE. To do so, there are preferences for this. You find everything for ease under the scripting node. And there we have those script locations. And I can tell Eclipse to monitor certain folders or certain locations for script files. And if we find script files there, we can do some fancy stuff with them, which I'll show you later on. So I'm adding now a workspace location and using the demo scripts folder. Typically it does recursive scanning. You can also push your scripts on a file system. Possibly you have a company file share and want to distribute scripts and share it with your colleagues. You can also load scripts from an HTTP server as long as you get those index pages that Apache creates by default. And now we have a few called Script Explorer that does accumulate these scripts. So all the scripts I had in here in the scripts folder, you can see here in the Script Explorer, and they're executable right away. So we had one script which is called create project. Let's first look at the code, what it does. Loading the resources module, the UI module, asks for input for a project name, and then creates the project in our workspace. Yeah, let's run it. And you can see we just created the full project in our workspace. Now, if it comes to those little helpers, it's nice to accumulate them in the Script Explorer, but it would be far nicer if we can put it into a more prominent location. So what we thought is, why not push a script into a toolbar or into a menu, or I will show you other places where it can pop up shortly. So for all these register scripts, we do support magic file headers. So if the script starts with a comment, we do look for key value pairs in there and try to interpret them. So if I want something in the toolbar, I say toolbar and provide the name of the view I want to push it into. So you could also provide the view ID if you know it, but typically the view name is much more prominent and you will find it more easily. So as soon as I save the file, please watch the toolbar up here. So clicking on save. And you can see our create project is dynamically created on the toolbar. So if you just consider what it means to push a button into a toolbar using Eclipse means, you do have to provide a plugin, you do need an extension point for a menu, you do need an additional extension for a handler for the command. You then have to provide the handler implementation, you have to provide a feature to zip this whole thing, to have a deployable feature, bring it to your target site, install it there, rerun it, and then you have a menu bar entry. 3 lines of code in scripting can do the same thing to you. This is also very interesting if you have special needs of certain customers. Maybe a customer does want an additional toolbar, but you do not want to push it to everybody out there. So you can provide your own little helpers in there. So what can we do else? Of course, the name isn't really fancy. 01 create project. Oh my God. So let's call it somehow differently. Just create P possibly. Please change. I had a typo in there. Thanks. Name? Yeah, now it works. So, and of course, if you want to have it even more fancy, on the toolbar you normally want to have icons. So why not use an icon? Now it looks really fancy, right? So our script is hidden here as an icon, and I still can run it right away by clicking the menu bar. We do provide several more keywords. So some of them will augment the UI. As you've seen toolbar, there is a menu entry that will push stuff into a view menu here. There's also a keyword called pop-up, which pushes a script into the pop-up menu of any kind of object you would like to. I'll show a sample shortly afterwards. We also do have keywords that react on events. Like I have here one that's called onSave, which means whenever a file of type JavaScript here, in that case, is saved, I want this script to be run. And the file instance actually is passed as an argument to the script. So I do also know which file got changed. What you can do with this is you can have a small builder, for example. If you have a custom build process and you want to trigger it somehow on file changes, that's the way to do it. Or a checker tool, for example. There's also something that's called onResourceChange, which means whenever you do a checkout or things like that, it triggers. So onSave just triggers when an editor saves. We do have keywords like onStartup, onShutdown, which is targeting the whole IDE. We do have onEvent. If you are familiar with the event bus in Eclipse, this is a generic broker system where everybody can push events to and consume events from, then you can react on such events and say, whenever an event of certain type occurs, I want a script to be run. Also, the nice thing is for these kind of scripts you see here, there's a service in background which you can query. You can ask it for scripts having a certain keyword, for example. So if you come up with your own keyword, which you can do, so we accumulate all these keywords in there, and some of them have meaning, some of them we do store, but we ignore them as we do not have handlers for them. But if you come up with your own keyword on database access or whatever you might come up with, you can trigger your own scripts on these kind of things. What you need for this is a listener for your dedicated event, and then you would search for the scripts using the script service and just call these scripts and run them. Here I do have a script which is called explore from here, and now I do push it to a pop-up menu. You can see we have an enable for expression here. By the way, is this readable in the background, or do we need larger font? Better? Enable for means, so I do want this pop-up just to be available for iResources, which are Eclipse resources in your workspace. Not only for things that are classic iResources, but also everything that's adaptable to an iResource, because not often you do have different objects in the workspace which just adapt to the workspace types. So what you can see is the explore from here appears in my context menu, right? yet it doesn't appear in the context menu here, because these things down here are not iResources. Another example I do like very much is you can bind your pop-ups also for text selections, for example. So I have a small script. I copied most of the code actually from the internet. This is just the API to communicate with Pastebin. So I can right-click and copy this stuff directly to Pastebin. I do get the URI back. Come on. And see, that's just the script code I selected and posted to Pastebin. So having these kind of helpers in your UI might improve your productivity, and it's quite simple to write such kind of scripts. So let me close this stuff. Now, when we came up with that scripting environment, as I said, the intentional idea was to provide scripting capabilities to users that are not well aware of scripting languages. So if you guys are the Java developers, you might say, well, I can do everything I can do in scripting in Java too. Why should I use a scripting language? So the main focus of people that are not so aware of coding and do need an easy yet extensible language. And when they came up with the scripts, the next question was, can we do testing with it? So can we provide unit tests in a scripted way without having to use JUnit? And what we came up for is a module called unit test, which provides the classic assertion methods you might know from JUnit, and along with some getter and setter methods to get tests, test cases, test classes, and so on. To keep it simple, we provided methods to tell the system when a test starts, when a test ends. So the most simplest form of writing test looks like this. This is spaghetti code, you would say, and maybe not the best way to write tests, but if you have people that are not aware of programming, it's a chance for them to write their tests. We do have a more object-oriented way too to write these tests. So this is a JavaScript object we are creating here with test functions, and we did invent something like annotations for JavaScript. I'm not sure if you know, but JavaScript doesn't have annotation support at all. But this is quite a fancy trick where I can push annotations in there, and we have some fancy stuff like expect an exception to be thrown by this method and so on, which is not possible in that simplified testing way I showed you before. When it comes to executing test, we added a so-called test suite concept. Test suites are XML files in the background, which gives some kind of control flow on what to test and how to test things. So the thing we came up with when we started with tests, users came up with, I do have parameters for my test. I do want to change things. And you do not want your users to play around with those JavaScript source files all the time. So what they can do here is they can first select which kind of tests do they want to execute. We do have include-exclude patterns. This is the AND style syntax, which you can use. And by clicking or unclicking or checking or unchecking the files here, you can closely say which kind of test do you want to run currently in my test run. You do have the possibility to define variables for your tests with some content. These variables will be dynamically injected in your script file. So in your script file, there will be automatically a thing called myVariable, which you simply can use in your script. And then you have some code injection points for a test suite setup or test file setup, what should happen before. Sanity checks typically to see if your setup is prepared to even run the test. Now, let's run it. You do see we implemented a view that looks quite similar to the JUnit test results view. We did have two tests that we had disabled. These were those two here. They weren't run, right? And the classic test, which had valid tests and invalid tests, a test that threw an exception, an error. So you do get error markers in your source files, so you know exactly where things went wrong and so on. You do have the possibility to export a report in JUnit format. This also supports headless builds and headless runs. So the whole test system is well integratable into a Jenkins build, for example, for a fully automated build. And of course, the same things count for those test classes we had here before. So for the modern test, you also do get your error markers and so on. Jump around in the files and see what's happening there. Script unit tests are currently supported for JavaScript and for Python, not for the other languages. So when it comes to deploy your scripts, it's easy as long as you have a simple file. If it's just one file and everything is contained in one file, well, send it over via email or push it to a share and share it with your colleagues. But what if your script needs some kind of resources? Some library to load, a jar file that you want to load additionally, images that you need, or other kind of resources. So you need to package it somehow and bundle it before you ship it to your users. Just to have a very simple example here, I've got a main file that includes the library here, and then just uses that library to print a result. So there's no magic in there, but how do I ship those things? How do I make sure people do copy both files when they want to use my script, and how do I make sure that do not rename it, for example, or push it into different folders and so on? So we came up with script archives. It's basically, a script archive is basically almost the same as a jar file. It's a zip file. We zip a project and we add a manifest to it. If you're familiar with executable jar files, there's a manifest in there, a text file in the end, where you have an entry there saying which is the main class you actually want to execute, which is the class that holds the main method. We do the very same thing, but instead of having main class, we do have a main script entry in our manifest, which tells us which is the entry script we want to run. So what I did, I bundled these two files in an archive. We call it SAR for script archive, but the engine will also trigger on JAR, on jar files too, and on zip files directly, if you prefer that naming. One way to run scripts is to right-click on them, say run as eScript. This also works, of course, for JavaScript files, this works for test suite files, this works for Python files. So everything that's supported by EAS can be run like that. This also counts true for SAR files. I did run it, you do see it, you get the result. And if you look closely here in the Project Explorer, I rerun it again, you will see something popping up. Did you see that? So what we do in the background is we extract that archive into an Eclipse project, into a temporary project we push into your workspace. So once your script runs, it has full access to the workspace, to anything you have here, even if it would be a good idea that the script archive is self-contained. Yeah. But it has access to the workspace if you need it to. The nice thing with those archives is I don't have to push a JavaScript file in there. I can push anything in there that's executable by ease. So what I did for this second archive, I used the unit test bench I had in the example before and pushed it to an archive. So right now I can run the whole test bench from an archive directly and ship it as one single file to my customers. Now I showed you a lot about JavaScript. That's the main topic I'm working on, but we do have support for other languages too. Most important one, Python. Python comes in two flavors. As I told you in the very beginning, there is Jython, which is an implementation on the JRE directly. Jython is quite fast as it runs on Java directly and can make use of all the Java classes, but it has a drawback. It cannot use native libraries from Python. So if you're using NumPy, for example, or any other numeric data crunching libraries, you will not have access to them. So if you want access to them, you have to use Py4j, which is that wrap-up between the Java world and the real Python interpreter. With Py4j, you can use any Python interpreter you want on your system. Just make sure there's a preference that we can find it on the system. And then we use that external interpreter and shove data back and forth between the interpreter and Java. So we can run this script. Clear that. Let me do it again that you can see the result. What you did see here, what I do a lot is push those files simply into the Rhino script shell. And you might wonder, why does the Rhino script shell, which is JavaScript, execute Python code? In the end, as you can see on the command, we're using a fork here. We spawn a separate engine and run them, and the results are printed to the same console. If we run it by right-clicking, the interpreter will get its own console as each script runs in a sandbox. They are boxed from each other, so they can see each other. We also do support Groovy. We support Ruby. And one very interesting thing is we support Jupyter. Anyone here that knows Jupyter? No? Jupyter was originally done for Python and is some kind of web notebook or web page where you can accumulate multiple things. So you can have cells in here that either contain just simple text written in Markdown, so you can have nice formatting in there. You can have cells that contain actually script code, which you can execute right away, and it could contain cells that contain output of script code. So what you do is, often this is nice for documentation or for a showcase that you want to show your customer. First explain what you're doing, then show those 3 or 20 lines of scripts you want to execute, and then immediately see the results, and all in the same HTML page. So you can just click in there, edit your code, change the text. If I click in there and run those cells, they will execute. I can have new cells in here, whatever, run it. So this is what Jupyter is all about. I'll show you one last example on Jupyter that has a little bit more context in it. The loading phase takes a little as Jupyter sets up a web server in the background that we need to connect to and so on. So there's a lot of inter-process communication happening. So this is, for example, one example where the execution of the script code yields in a plot that you might want to display, like for measurement results or things like that. Jupyter Notebook, or generally when you use Py4j, which is used in the background here, has a penalty on performance. As you have heard, we have inter-process communication a lot between Java and Python. We do need to serialize and unserialize data a lot. So this means this is not the best performance way of doing things, but this is more for an interactive working with things and showing people what to do and teach them how to use your libraries, for example. This is an overview of the currently supported script languages and engines that we do have. You can see all of them can be launched at least. Some of them do have shell. Not everything has a shell, like the unit test thing doesn't have a shell, of course, where you can interactively work with it. Some of them do have debug support, others don't. This table is also available on our webpage in our documentation, so you can check out which engine might fit your needs best. Okay. This is the end of my talk. I do want to ask you to evaluate the sessions. This is very important for us to get feedback. Perfect is if it's not just plus, minus 1, but a small note to tell us what was good or what was bad. Thank you very much. If there are any questions, please speak up or come forward. I'll be around for the whole conference.